Welcome you all in lecture number 27 of Engineering Mathematics 1 MTL 1025. In this lecture, we are again going to discuss the change of order of integration and triple integration. Okay, so let us see change of order of integration. So let us see how to evaluate the double integral xy dx dy over the region A. What is the region A? Region A is the positive quadrant of the circle. Okay, so this one, this is the circle x square plus y square equal to a square. It is center with 0 0 and radius is a. Okay, in this quadrant we have to evaluate this integral. This is our region A. Okay, this is our region A. Then the integral is evaluated as, consider any strip. Okay, consider any strip either parallel to x-axis or y-axis. If we consider the strip parallel to x-axis, say this one, then lower portion of this strip come to this part and upper portion up to this part. And what is this? This is 0a. And what is this point? Origin, that is 0 0. So double integral y equal to 0 and upper limit y equal to a. And for lower limit of x, what is this line? This line is y-axis, that is x equal to 0. And upper part lies on this circle, always lies on this circle. What is the equation of circle? A square equal to x square plus y square. Then what is x is equal to? A square minus y square. Okay, so square root of a square minus y square. xy dx dy. What is this? This is equal to y. Okay, so evaluate this integral first with respect to y and then with respect to x, right? And find the value of the integral. Okay, now let us see another problem for change of order of integration. Okay, see this problem. This problem, see this problem very carefully. The region of integration is bounded by, the region of integration is bounded by following curves. Number one, see the limit of internal integral is function of x, so it is limit of y. It means y is equal to x square by a, that is x square is equal to a y. It is lower limit. Okay, second, y is equal to 2a minus x. This implies that x plus y is equal to 2a. This is the upper limit, right? And third, x equal to 0, that is the y-axis. And fourth, x equal to a straight line parallel to y-axis at a distance a from origin. Okay, and what is this? This is the parabola. This is parabola opening upward direction. And this one is the straight line. What is this straight line? X by 2a, y by 2a equal to 1. Okay, so the region of integration is bounded by the following curve. Okay, now let us plot these curves. See, this is the parabola, right? X square is equal to ay, right? And x by 2a, y by 2a equal to 1. It means, say this is 2 1 and this is y axis, this is x axis, this one. What is this straight line? X plus y equal to 2a. Okay. Now x equal to 0 is the y axis. X equal to 0. Next, x equal to a. What is this point? This point is AA. Okay, this is the point of intersection. This point of intersection is A. This point is 2a0 and this point is 0 to a. Okay. Now x equal to a. Come to the point x equal to a. What is x equal to a? X equal to a is this straight line. So region bounded by all four curves is this one. This is the region. See carefully. This is the region bounded by these four curves. Okay. Now, what is change of order of integration? Okay. What is change of order of integration? See, this integral we have to evaluate first with respect to y. Since it is the function of x, we have to evaluate with respect to y and then b with respect to x. Now we want to convert this integral with certain limits such that internal is the limit of function of y. Instead of function of x, it becomes the function of y. So evaluate this with respect to x first and then dy. With change of order means here we have to evaluate first with respect to y and second with respect to x. Then change of order means evaluate first with respect to x and second with respect to y. Okay. Now see. Consider a strip. Let us see this strip. Okay. This is not a strip. This is the line which divides the whole region into two parts. Okay. So this region is say D1 and this region we can say D2. Now consider the strip parallel to the consider this region parallel to the y-axis. Okay. Then this double integral over D2, the lower limit will come here and upper limit up to here. It means y equal to 0, here y equal to 0 and this straight line is y equal to a. Y equal to a. And lower strip is lies on this straight line, that is x equal to 0. And upper strip is lies on this portion. What is this? X square is equal to ay. It means x is equal to square root a y. Okay. And it is function of xy dx dy. Okay. Plus, come to the second part. What is second part? Consider the strip. The lower portion come to this straight line. It means y equal to a. And upper portion up to this point, y equal to 2a. Okay. Strip lower portion is lies here, that is x equal to 0. And upper portion up to here, that x is equal to 2a minus y. Okay. And function of xy dx dy. Okay. So this single integral is converted into two parts, this one and this one. This integral first evaluated with respect to y and second with respect to x, and these two integral evaluated first with respect to x and second with respect to y. Okay. So this is the change of order of integration. Okay. Now come to the triple integral. One more example. See the order of change of integration. Now see this integral carefully. You can evaluate this integral. Now try it. whether you can evaluate or not. Okay, then write it in the comment section. Okay, now if we evaluate this integral by change of order of integration, then what is the process? Process is this one. First, we have to see the region of integration is bounded by the following curve. What is the curve? Limit of internal integral is function of y, that is y equal to 0, this is straight line, y equal to x, this is straight line, x equal to 0, y axis, x equal to infinity, and this one, this is the whole region up to infinity. Okay, this is the whole region up to infinity. Okay, okay. Now see, the change of order of integration means this integral first we have to evaluate with respect to y and second with respect to x. Since the internal limit of internal integral is function of x, so evaluate first with respect to dy and then with respect to dx. Change of order of integration means to make this integral into such a form, we have to evaluate first with respect to x and second with respect to y. This is the change of order of integration. Okay, okay. Now let us consider a strip parallel to the x-axis. Okay, this is the strip. See, the lower portion of the strip is this straight line, that is y equal to 0. Okay, y equal to 0, and upper portion is lies whole region, that is the infinity, y equal to infinity, and lower portion is lies on this strip. And what is the straight line? X equal to y, this is x equal to y, and upper portion is lies at infinity, that x equal to infinity. Okay, e to the power minus xy, y, then dx first with respect to dx and then dy. Okay, now you can see this integral is easy in comparison to this one. Okay, you can easily verify it, and the value of the integral is 1 by 2 square root of pi. Okay, now come to the triple integral. See, triple integral, the evaluate this integral. Limit is not given, but the region is bounded by the following curve: x equal to 0, y equal to 0, z equal to 0, x plus y plus z equal to a. Okay, it means, see, it is triple integral and region by bounded by the following curve. The region is bounded by these curves. Now, is three-dimensional figure, so you can visualize this three dimension. Okay, see here, this is x, y and z. Okay, so this plane is z equal to 0, this plane is x equal to 0, and this plane is y equal to 0. These are the coordinate plane. Xz plane means y equal to 0, yz plane x equal to 0, xy plane z equal to 0, and one another plane, that is x plus y plus z equal to a. So x by a, y by b plus z by c, y by a, z by a equal to 1, right? So this is the plane ABC. The plane ABC is x by a, y by a, z by a equal to 1. This is the plane ABC. Okay. Now to evaluate this integral, in evaluation of integral is easy, but you have to know how we have to put the limit. See, x equal to 0, y equal to 0, z equal to 0. What is the upper limit of z? See from here, z is equal to a minus x minus y. This is a minus x minus y. Okay, and function is same, x square, y square, z square. First we have to evaluate with respect to z. Again, since x plus y plus z equal to a, take projection of this plane, projection of this plane on z equal to 0 plane. It means x plus y is equal to a. And what is y? Y equal to a minus x. This is the upper limit of y. Okay. Again, if y equal to 0, then what is x? X is equal to a. This is upper limit. So first we have to evaluate this one first, then y second, and then dx, that is the third. Okay. So evaluate this integral. Evaluation of integral you know, and find out the value of this integral. This is the triple integral. Okay. Now come to this integral. The same problem is this one, right? The region of integration means this is triple integral R, and this one is the function dx dy dz divided by 1 plus x plus y plus z whole to the power 3. So function is 1 by 1 plus x plus y plus z to the power 3. And what is R? R is the region of integration bounded by coordinate planes. Okay, bounded by coordinate planes means x equal to 0, y equal to 0, z equal to 0. Yes. Then the limit of integration, again x equal to 0, y equal to 0, z equal to 0. And bounded by this plane also, x plus y plus z equal to 1. Okay, so what is z? 1 minus x minus y. Okay, if we take the projection on xy plane, then z equal to 0. What is y? Y equal to 1 minus x, and limit of x is 0 to 1. Okay, 1 by 1 plus x plus y plus z whole to the power 3 dz dy dx. First with respect to this, second with respect to y, and third with respect to x. Okay, so evaluate this integral. Okay, now see, just like from Cartesian to polar coordinate, what is x? X is equal to r cos theta, y equal to r sin theta, where from Cartesian to polar coordinate. From Cartesian to polar coordinate. Okay, from Cartesian to polar coordinate. Okay, in the same fashion, in three dimensional, we have to plot spherical polar coordinate. Spherical polar coordinate. And this one is first, and second one is cylindrical polar coordinate. Cylindrical polar coordinates. Okay, so first we will see what is the spherical polar coordinate, Cartesian to spherical polar coordinate. Okay, so x is equal to r sin theta cos phi, right? X square y square z square equal to a square, right? Sorry, r square. Then x is equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. Now find the Jacobian of this. J is equal to dou of x, y, z and dou of r theta and phi. This is equal to r sin square theta. Then dx dy dz is equal to Jacobian of dr d theta d phi. Okay, what is Jacobian? R sin theta. R square sin theta. R square sin theta dr d theta d phi. Okay. No? And what is the limit? If the equation of a sphere is given in this form, that is, equation of a sphere is x square y square z square equal to a square, then r value of r is given from 0 to a, and limit of theta from 0 to pi and phi from 0 to 2 pi. Okay, remember this thing, r from 0 to a, theta from 0 to pi, and phi from 0 to 2 pi. Okay, let us see one example. Evaluate this integral, x square y square z square dx dy dz. Right? Either you can use Cartesian form or you convert it into the spherical polar coordinate. In spherical polar coordinate, we know that what is x? X is equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. Then what is dx dy dz? R square sin theta d theta d phi dr. Okay, x square y square z square equal to r square. Okay, what is the limit? Since x square y square z square equal to 1, so r varies from 0 to 1, theta varies from 0 to pi, and phi varies from 0 to 2 pi. Okay, so this is limit of r, theta and phi in same fashion. First we have to evaluate with respect to r, then theta, then phi. Okay, evaluate this integral. This is the value of the integral. In same way we can solve this, but it is written as first octant, right? Just like the first quadrant in 2 dimension, first octant in 3 dimension. If the first octant is given, then r limit is same. Okay, r limit is same, but theta and phi limit changes from 0 to pi by 2 and 0 to pi by 2. Okay, and every the rest things are same. R varies from 0 to a, theta varies from 0 to pi, phi varies from 0 to pi, theta varies from 0 to pi by 2, phi varies from 0 to pi. And integral, evaluate this integral. Okay, this is easy. Next lecture we will continue from here onwards. Okay.